Hey YouTube, welcome back. Today is the 12th video of our series of system design and interviews, and so we are designing a rate limiter. And basically today we will talk about we have talking about the understand the problem. We have talked about understand the problem. We talked about the proposed high level design, and we're right now with finishing the deep dive. If you didn't watch the previous video, I highly recommend to watch them. If you watch them and you just want to make a quick recap, I will make a quick review here. Basically, we had the question design, the design a rate limiter, and as we always all the time, the system design interviews start with a vague question. And our duty and our tasks is to ask to request clarification, so we understand the problem and we know the requirements. So basically, we have this to understand to know the problems and the requirements. We just ask these questions, and we just from the question we need to ask from 5 to 10 questions, and from the question we get the functional requirements and non-functional requirements. And I will not go through them because I have to make like I have did tons of recapping, so I guess that you can just read them. And after that we propose a high level design. So basically we talked about three things. Is that where should we put the rate limiter? We said that we should put client or server, and we talked about we should put in server and instead of on the client, because we have a control on the client, and we can put it on the API service, or can put it as in the API gateway. Depends on the architecture that we're using and the technologies that we're having. And also we talked about which algorithm that we use, and we have the token. Let's just get like that. Okay, we have the token bucket, linking bucket, fixed window bucket, and sliding window log, and sliding window counter. And we talked about the pros and cons on each one of them. And after that we started to talk about where should we store the counter basically. And we had two options to store it in a proper database, not proper database, in a SQL database or like a disk database. But this one will have some sort of latency, so we choose to use a Redis. Redis is in memory database. Basically, it requires super low latency, and it has the increment and the expire to basically, so we can use them. And after that, we talked about how we can how we can communicate with the user basically. And basically we send the user. We talked about the rules, and how actually the rules look like, and how we will communicate with the user. So user will get limited, we just give him a request of 429, and we have like three variables. We put them in the header, so the client will know if it's rate limited. After a period of amount of time, he could or she could try again. What is the rate limiting, what is the remaining, and basically, yeah, things like that. And after that we talked about the design in detail. So basically we talked about the client, and basically on this design, just I start to go into detail. The client went to basically we start from the rules, because if we can start from the rules, so basically the rules, we store them in the disk, and the workers are pull the rules from pull the rules and store them in the cache. And basically when the client sends any requests, basically it's directed to the rate limiter first, because before it went to the server. The request is basically basically it's sent to the rate limiter. Basically the rate limiter loads the rules from the cache, and actually it fetches and fetches the counter from the Redis database. And depending on that, it just to compare the counter with the limit. And depending on that, we can, if we the rate limit decided to process the request or drop it. When we drop the request, that we can when we don't accept the request, we can just drop it or put it in the message queue. Depends on how the request is important. And basically we got to the one of the final solutions. It is basically we have right now our system, and we want to scale it. Right now we want to work in a distributed environment. Okay, and while working in distributed environment, we will have two problems basically. Just can we like Okay, when we're working with distributed environments, basically we had can we make this one like thicker? Yeah. Yeah. Okay. Okay. And basically, when we're working with distributed environment, we will have two problems. Basically, a race condition problem and synchronization issue. We will talk today in this video about the race condition problem. Basically, as discussed before, let's say that the rate limit works as we said before. That basically we read the counter value from Redis, check if the counter +1 exceeded the threshold. If not, increment the counter increment the counter in Redis by 1. Okay, otherwise drop the request. The race condition, let's just talk about the race condition here. So basically the race condition is pretty straightforward, that we could have request 1, okay, and also we have request 2, okay. And both of them are connecting, making a request to the backend, and basically both of them are increase the counter. Basically, I would say counter plus. Both of them actually doing the same, but the problem that both of them doing this in the same time. Okay, so basically the problem, the race condition actually can heal in the high concurrent environment, because we are distributed system, so we got tons of requests at the same time. So basically, if assume that the counter in value here is 3, let's assume that the counter is 3. The counter right now is 3 basically. And if two requests are concurrently read the counter value before either of them write the value back, for example, both of them, they are reading at the same time, so both of them will read 3. And each one of them will increment the counter by 1. So instead of we get 5, we will get 4, because both of them are updating the database in the same time. And basically this race condition problem, we can solve it with something called Lua scripting. Basically, Lua scripting is a powerful feature of Redis that allows for the execution of complex operations. For example, that we have this one of the complex operation on the server side. It can use to implement automatic operations and solve race condition in Redis. Basically, let's just give an example basically of how actually Lua script and data structure in Redis can be used to solve the race condition. Suppose that we have basically a system where multiple clients can basically, let's suppose that we have system with multiple clients can update a counter in Redis at the same time. If 2 or more clients try to update the counter simultaneously, the race condition can occur, and actually the counter may not be updated correctly. So basically we have 2 updated, so the counter should be 5, but because they're updating in the same time, the counter will be 4. Basically, to solve this condition, we can use something called a Lua script and a Redis data structure called mutex. Basically, which is a lag that allows only one client to execute the script at a time. So basically that's it. There is some more complex, but I guess you only need to say this thing, so you don't need to say more than that. And basically this is the way that we solve it. It's that we will use the Lua script, and what was the name? The mutex data, Redis data structure, the called mutex, to make sure only one client is connecting. And basically that's it for today's video. I hope you like my description. If you like the video, make sure to feel free to subscribe, hit the notification bell, so you will never see a video. So you will never see a video. So you will never miss a video. I hope you will never miss, not see. So you will never miss a video. And yeah, that's it for today's video, and see you in future videos.